Hey everyone, really excited to be here to talk to you about how you can make deployments more flexible, easier, and more reliable with feature flags and hopefully also with OpenFeature. I'm Todd Baert. I'm a maintainer of the OpenFeature project, and I'm from Dynatrace. If you're not familiar with Dynatrace, it's an observability platform. We don't sell feature flags or do remote configuration of any kind, so you can be assured that I won't sell you anything during this presentation. Yeah, I guess to get right into it, I should start by saying OpenFeature is a standard for feature flags. We're part of the CNCF, so actually I'm super grateful to follow Tiffany because she explained a lot of stuff relevant to our project and my presentation. So we are in the CNCF, but before I can really talk too much about OpenFeature, I think that I need to talk a little bit about feature flagging. I learned that the hard way because quite a few times I've tried to talk about the project and realized that the people or person I'm talking to really has a different understanding of feature flags than me. So I think we have to kind of level set on that definition. I think the first time I actually realized that was after we got accepted as a sandbox project in the CNCF. We got some press. I say press, and it sounds like we were on the New York Times. It was just like tech press, right? So tech Twitter and stuff. But somebody posted an article about OpenFeature on Hacker News, and then they said, like there's a lot of positive feedback. People were really excited about the project, and then a lot of people saying like, I don't get it. And I remember there was a top-rated comment that said, why would I want to add a dependency for toggles? And that just sticks with me to this day because I think there's a good question rooted in there. And I think by the end of this presentation, I hope I can convince you that it's worth it. It's probably worth adding a dependency for feature flags. So I think the best way to explain feature flags is really to ask the question, what is a feature flag? Or the best way to answer the question, what is a feature flag, is to kind of look at the problem that people are trying to solve when they employ them. And I think that whether you're a software engineer, an SRE, somewhere in between, you've probably had a problem like this. You found yourself in a position where the code is ready, but for some reason you can't deploy the feature. So it could be a legal or compliance reason. It could be because there's a press release pending or a release pending. It could be that there's another team that you need to wait for. There's tons of reasons why this can happen. Well, no problem. We have a 10x engineer. And they've come up with this brilliant solution. And it looks something like this. We're going to read an environment variable. And then if the environment variable equals true, we're going to do our new thing. And if it doesn't, then we're going to do our old thing. And you can kind of see something like that up here. It's just a couple lines of Java. I hope that's readable. And like you might ask yourself, well, is that it? Like, is that feature flags? Am I here just to tell you how to read environment variables from your application? No, I think we can do better, and I think it's worth it to be better, to do better. But you don't have to take my word for it. I have a few quotes here. eBay says, being able to alter runtime behavior without deploying means we can quickly mitigate issues, enable features for subsets of production users, and perform A/B-style feature tests. eBay has contributed hugely to OpenFeature. We also have a quote from Pete Hodgson on Martin Fowler's blog. Feature toggling is a set of patterns which can help a team deliver new functionality to users rapidly but safely. And we also have a quote, a tweet here from Charity Majors. I consider feature flags an absolutely necessary component of a modern software development pipeline, so much so that I keep forgetting to mention them, facepalm. Decouple your releases and deploys people, it's worth the time investment. I didn't ask Charity before I used this tweet. I hope that's cool. To be honest, I did not know she was going to be here when I wrote this slide either. So that was pretty cool how that ended up happening. So let's go back to our previous fictional feature, our cow-say feature. And I'm going to ask a few what-ifs here. And I think they're all pretty realistic. Maybe you'll relate to some of them. What if the feature is implemented across multiple services? So then we have to coordinate that environment variable in multiple places. Like one environment variable in one service is one thing. 10 environment variables in 10 services overlapping is another thing. What if there's another option suddenly required? What if it's not just a Boolean now? Like, what if we want additional options? Like, I don't know if you're familiar with cowsay, but there's a formatting option, and you can make Tux, the little Linux penguin mascot, say your message instead of a cow. There's also -s and -t. I won't go into all the cowsay options. You can read the manual if you're interested. What if we want to enable the feature for only one customer? What if we want to enable the feature for a subset of customers, maybe all paying customers? What if we want to enable the feature pseudo-randomly and see how it impacts usage or performance? And a caveat here, if we want to do this, we probably want to make that assignment, the assignment of that variant, sticky, because we don't want the user's experience to change like page load to page load or app visit to app visit. We want it to kind of stick with that user for some amount of time at least. What if we want to progressively roll out the feature to everyone? So we want 1% of people to have it, and then 5%, and then 10%, and then 100%. So I've presented all these problems, and I have a solution, I think. And my solution's inspired by the Richardson maturity model, which is what you're seeing here. The Richardson maturity model is basically a way to, like, it's a hierarchy to understand how to write idiomatic REST services. I'm not going to dive too much into it, but I really liked it. I remember it made things really clear to me when I was first learning REST, and I kind of wanted to use that to talk about patterns and practices for feature flags. So introducing the feature flag maturity model. It's zero index, obviously, because we're in software, but it starts in the nvar swamp, and then we have dynamic configuration, dynamic evaluation, and finally operationalized feature flags. I'd like to quickly go through this model and what I think it offers. So level 0, we basically already saw, it's primitive feature flags. You need to change the configuration, you typically need to redeploy, at least cycle your application. Maybe you need to recompile it. There's no contextual awareness, so we don't know who the user is or who the service is or where the service is running. That's not a factor in our evaluation of a feature flag. There's little or no meaningful telemetry data, and again, we'll go back to the cows example that I hope is readable. Can you guys read this? Yeah, okay, cool. Okay, dynamic configuration, this is the next level. So I would say this, either the last level or this level is where most of the orgs I've worked in or consulted for, where they find themselves. So in this situation, configuration can be changed without a deployment or recompilation of the workload. So the feature flag source of truth is kind of independent of the application and maybe can even be reloaded dynamically. And we maybe have some primitive contextual awareness. So there's some really basic logic that is probably duplicated in multiple services in evaluating a feature flag or evaluating a flag. Here's an example of that. So it's not too far off from our previous example. You see here we're using some like hypothetical flags service. We're getting this list of geographies, and then we're seeing, hey, does the user belong in this set of geographies? Like, is this user datum in that list? And then we show, we do it with the cows if they are. This is cool. I see code like this. I've seen it a lot of different places. The problem is that this is duplicated everywhere. So it's not a robust basis for experimentation. It's duplicated everywhere, and it's still, again, to change that logic, you need to do a redeploy. Like if you wanted to add another variant here, variable here, I guess, or another factor, like say you want to show it to everybody in Toronto, but also anybody named Todd. You need to bake that into your app again, all your apps again, and redeploy them. So this is the next level, level 2, dynamic evaluation. So here is where things get really interesting and powerful. The problem that I just identified is really addressed. We take the expressions that we have in code and we centralize them into a management system so that you can write those expressions and those rules in code, and your actual deployment is not polluted with this ugly kind of feature management code, as I like to refer to it. And some of the vendors that we work with and that actually support OpenFeature, I've taken screenshots of their UI where we're kind of doing something comparable here. We're saying, is a user in one of these geos? You see something similar here with a different vendor. And then finally, this is an actual percentage split. So this isn't a rule per se. This is just saying, I want you to split the feature flag evaluation to these 4 variants, 25% each. So the other thing about level 2 is that the evaluation is fully observable. So we see traces and spans, they're annotated with data. We have metrics about feature flag evaluations, including what variant was returned and why, like was this the result of a rule match, a random split like I was just showing. And we also have any relevant contextual data that we want in our telemetry system. Being careful about PII, that's something to think about. The last level, operationalized feature flags, I don't really see very often. Technically, this is all the same stuff as what's in level 2, but it's really about how it's used and how well integrated it is into the business, in my view. So in this situation, flag telemetry data and flag management, it's made accessible to all the relevant business units. And it's basically turned into an asset so that all parts of the business can use it to do experiments, to safely roll out releases. It's not a free-for-all. You probably want some kind of RBAC or some policies dictating how flags can be changed, who can do them and when, and with what kind of constraints and checks. But feature flags are leveraged, for example, in ongoing experimentation. So you can do hypothesis testing like, does feature X improve conversion rate? Does UI element Y reduce bounce rate? And then you can actually test those hypotheses. You can do canary releases and reduce blast radius when you do a rollout of a new feature. Like I said, you can roll it out to 1% and see if there's increased error rates there. And then this is something that I think is pretty powerful too. You can do opt-in beta or previews. A lot of times there'll be customers that will request access to a feature, but you don't want to put them in like a beta environment, like all their data is in prod anyway. So you can just have them, have a feature flag that specifically targets like users who log in from their domain or something like that, or from their IDP. There's probably a number of ways to do it. So that's it. That's my concept of kind of a feature flag maturity model and all the things it can kind of bring to your organization. I guess the question that you might be thinking is like, okay, well, how does OpenFeature solve these problems? How does it help? And that's what I'd like to explain next. So again, I'm going to explain a little bit of what OpenFeature is. It's an open standard that provides a vendor-agnostic, community-driven API for feature flagging. So we have 5 SDKs already at 1.0 released and in production at various places. You can see the languages we support. We have more coming. I'm going to ask at the end for help because we definitely need help with Python and Ruby especially. So if you are a Python and Ruby engineer and you want to become involved, please contact me after. We're desperately looking for more maintainers for languages we haven't finished yet. The standard was developed in collaboration with a lot of the top vendors in the space. So I want to enumerate all these. Like basically all of the feature flag vendors have been involved in the project. So they support it one way or another. A lot of them have basically released adapters so that you can use OpenFeature with their product, as well as open source projects as well. Why standardize? This is a great question. So this is kind of our textbook answer that we put on our website. I really think the second sentence here is the most interesting one. It provides a framework for building extensions and integrations that can be shared across the community. And this is like my personal answer. It's like kind of like a word cloud. I think the most interesting one, again, is that like bigger green one, common paradigms for ecosystem development. You can do all kinds of really interesting integrations if you have a standard. And that's kind of what I'll be demoing later. So now I'll do a really, really quick crash course of OpenFeature itself, some of the artifacts in OpenFeature, some of the abstractions, and then I'm going to do a live demo. So we're going to end on a live demo. I get secondhand anxiety when I watch people do live demos. So I've done something as a favor to all of you, and I've pre-recorded my demo as well. So if the demo doesn't go well because the network's a little slow, I'm just going to play a video. But hopefully we can actually do the live thing, so we'll see what happens. Anyway, the 3 things I'd like to introduce, this is the first of them, the evaluation API. This is kind of the heart of OpenFeature in a lot of ways. It's the vendor-neutral flag evaluation API. It's a standard interface for evaluating feature flags. So it might be a little bit small there, but it basically looks a lot like our Cowsay example. It's just a little bit better structured, and you'll notice the second line here has something interesting, api.setProvider, new myProvider. And that's a good segue into the next slide. So the provider is the adapter layer for our flag management system. So this interface is defined in the SDK, and it allows the evaluation API to work with whatever backend you want. So this is kind of where the flexibility comes in, right? So if you're a vendor, you simply write a provider for your feature flag backend and you publish it. And that's what a lot of vendors that work with us have done. But if you have kind of a feature management system that you're working with in-house, you can use that. You can just write a simple provider. It's a few methods you have to implement, and then you plug it into OpenFeature and you can use it. And then you can move to a vendor when you feel like it, if you feel like it. And your initial provider may do something as simple as reading from a flat file. It's up to you. You can call a REST API, be backed by a database. That's totally up to you. And then the last abstraction I want to introduce is a hook. So this is our integration point. That's definitely too small to see. But basically, the hook allows you to plug into various places in the flag evaluation lifecycle, as we call it, to do basically whatever you want. You could send data to a telemetry system. You could annotate a span in OpenTelemetry. You could send data to a user analytics application if you want. Any of this stuff is possible. You can enrich the data, the user context data, for instance. Okay, so now demo time. What am I gonna show you here? So this is basically like a real-time vendor-neutral feature management platform, kind of built from scratch from cloud-native components. So OpenFeature, as well as a whole bunch of other CNCF projects that Tiffany just showed you in the CNCF landscape. So I'm going to highlight a couple for you here. The OpenFeature SDK for JavaScript is what we're going to be using to evaluate flags. FlagD is going to be our provider. So that's going to be our flag evaluation backend. Now, FlagD, is important to note, is kind of maintained by the OpenFeature project, but it's not OpenFeature per se. It's just our reference implementation for a backend. We use it in a lot of testing and demos. It's kind of like a flag evaluation daemon. It's like a Unix philosophy, very minimalistic binary that just does flag evaluation. Can run as a systemd service, can run as a sidecar, just a very small binary. And then we have the associated provider for JavaScript so that we can communicate with FlagD from our code. And then we also have Argo to kind of manage the deployments. And we're going to show an integration with OpenTelemetry, which is where I think things get, like I said, really interesting. And here's like a tiny diagram that might help you. So yeah, we'll have the FlagD instance, the FlagD provider, and our OpenFeature SDK all running in our pod. And then we're actually going to be storing our feature flags themselves in a custom resource in Kubernetes. So FlagD, as you may have read here, it basically can take its feature flag source of truth from an HTTP endpoint, Kubernetes custom resources, flat file, a whole bunch of options. We're going to be doing all this in Kubernetes. You don't need to, but that's where I'm going to demo it, and we're going to use custom resources as kind of the source of truth for a feature flag. So hopefully you guys can all see this. It's not too cut off. This is a Kubernetes cluster I've had running for 60 minutes now. I just set it up backstage. It's not too interesting. I have Argo, I have Cert Manager, so this is like kind of just to manage certificates within the cluster. Argo CD. That's like Tiffany mentioned. It's basically a way to deploy resources from Git. Basically, keep the state of your cluster in Git and synchronize it. And then we also have our demo application running with FlagD as a sidecar here, like I was mentioning. So hopefully that's clear to you guys. And I'm going to show you the application now. Okay, great. So extremely valuable software as a service company, Fibonacci as a service, okay? They're delivering Fibonacci to people. It's critical. So basically, the way this app works is I can click this button, and it's going to, wow, it's taken a really long time, but it's going to calculate Fibonacci for me at some number. So here we're doing 40, and we got an answer. Great, it took 4 seconds. That was really long. Let's see if it's a fluke. Nope, it's taking long again. Let's see if we like crank it down a little bit. Let's see if it's any better at like just fib at 33. Oh boy, that's still really slow. So yeah, this is like the core of these guys' business. So they want to optimize this. They need to make some changes. Luckily, they're working on like a secret algorithm to calculate Fibonacci faster, and they've actually put it behind a feature flag. So what you see here, I'm going to skip over our app here, but I'm going to show you the custom resource definition. So this is a custom resource in Kubernetes. I'll do my best to make this legible for you guys, sorry. We have a custom resource basically for two sets of feature flags. One for client-side flags, so there's one for the welcome message and the color, and then there's a server-side flag that's evaluated on the server that controls the Fibonacci algorithm we use. So I'm going to go ahead and I'm going to change this to, I think this is pronounced Benet. It's a fast, correct me if I'm wrong, if anybody knows it, it's a fast algorithm for calculating Fibonacci at much faster. It's like, I think it's a linear time, to be honest. And I'm just going to go and I'm going to commit this change. And I'm going to push this up. And what should happen here, hopefully it doesn't take too long. Make sure I'm still logged into Argo. Yeah, so in a couple seconds, Argo's polling my Git repo, and it should see that I've changed this feature flag. And in a second, it should say that I'm no longer synced. And we'll see that any second now. Like I said, the internet's a little bit slow, so hopefully it doesn't take too long. There we go. Okay, so here you can view the diff. It's basically just what we did. I changed the default variant from recursive to Benet. And now I'm going to go ahead and sync this, and that will deploy it to Kubernetes. Fantastic. And if I go back to my app now, whoa, that's way faster. So the new top secret algorithm is great. You can see, well, what happened there is basically flag D got a new request. It saw that the state of this feature flag had changed, and it then used the new algorithm, which was in our code. And you can see even at 40, it works much better. Okay, let's do something maybe a little bit different, and hopefully a little bit more interesting. I'm going to look at some of these UI feature flags here, and I'm going to change this one to green. Now, you may be curious about what this YAML is. So if you're not too familiar with Kubernetes, basically, what this YAML represents is a custom resource. So it's a resource we've called feature flag configurations. And flag-D understands these resources in Kubernetes and uses them as a source of truth for feature flags to do evaluation. Now, it could be flag-D can be reading from a flat file. Because Kubernetes is interesting and it makes for an interesting demo, we've chose to run all of this in Kubernetes. And it really emphasizes the kind of cloud-native integrations that are possible. But I'm going to do the same thing. I'm going to update this value. I think I changed it to green. Yep. Push that up. And I'm going to split this out for a second, because this is going to be quick. So again, any minute now, we should see Argo detect drift, and then, yep, we do. And I'm going to go ahead and just, I won't even look at the diff, I'll just synchronize this, and bam, our UI is turned green. So how did that happen that fast? Well, a lot of feature management SDKs have eventing, so OpenFeature does too. So basically, you can set up events and push them all the way to the UI that say, if a flag changes, even with no user interaction, like nobody clicking a button or whatever, the source of truth has changed, and we can push that out to consumers and make changes in our app without any user interaction. So that's kind of what you saw there. There's one more thing I'd like to demo here. This one's going to be a little bit trickier. Hopefully I can get all my syntax right. I'm going to add a new variant. It's yellow, and I'm going to add a targeting rule. And I'll do the condition in a second, but I know I want it to return yellow. If I don't return yellow, I'll just return null, and we'll fall back to default. So our condition is going to be if in so this is actually a syntax called JSON logic, which allows you to write simple expressions in JSON, or in this case, YAML. I'll explain exactly what this means in a second. So this is basically saying, okay, so if, and actually this should not be an array, I that's right, okay. So basically this is saying if my syntax right here, if our user has this string in their email, then we want to return our new yellow variant. So this is kind of a targeting rule. Like I said, we've extracted some of this stuff from our application logic, and now we're putting it in this case, custom resources. It could be in a UI and a feature management platform. It really could be anywhere. But we're using this in custom resources in Kubernetes. So I'm going to go ahead and commit this. Hopefully I don't have any syntax errors here. And we should see again in a few seconds. So now what flag D is going to get is it's going to get not just some static assignment for feature flags, it's actually going to get, for one feature flag, a rule. And that's what we just did. So I'm going to push that out, hit synchronize here. Sync failed. That's interesting. I feel like that's because there's something wrong with my rule. I think we actually want that. Hopefully I'm not developing a case of demoitis here. We'll see. Oh, did I? Oh, thank you. Hopefully we can resync this now without an error. Sync error still. Oh, okay. Yeah, I think it looks like we've lost internet connection to the remote repo. That is a bummer. Yeah, so we may just, I may not be able to to demo this, unfortunately. Let me try. I'm actually on my hotspot, so let me really quickly switch and see if we can do one more time. But if not, might move on here. Okay, I'm going to skip this part. What you would have seen if this is working, and maybe there's a chance that we actually have synced and it's just not showing. I doubt it. Yeah, what you would have seen here is when I logged in, the app would turn yellow if we could actually connect to Git. There's one more thing I'd like to demo for you here. That's this telemetry integration here. So this is probably one of the most interesting things, like I was saying, is these kinds of integrations that are available now with open standards. So I'm going to open Jaeger, and we're going to, if you recall, we're going to look at our Fibonacci algorithm stuff. So we actually we can actually query based on feature flag values here. So this is a quick query in Jaeger. And we have telemetry data, and I'll tell you why we have telemetry data. We've attached a hook as part of our flag evaluation. And this is one that we actually publish as part of the OpenFeature project that allows kind of seamless, with one-line telemetry integration through OTel. So we actually instrument the code around around feature flag evaluation, and this will work with basically any provider. It doesn't matter. This is just kind of a plug-and-play thing you can get with OpenFeature. So if we drill down to this trace that took 4 seconds, you can see our span event here. And you can actually see the Fibonacci algorithm key that we changed. The variant we got was recursive. Well, that's kind of interesting. All these clustered up here took about 4 seconds. And you can see that we have a couple that were a little bit quicker. Well, okay, let's go again. Now, obviously, you guys know the answer of what happened here. But if we go back down to these span attributes, you can see here we got Benet. So if I go ahead and copy this span attribute, I can search for Benet. And just to prove out our theory that, this algorithm is faster, I'm going to say, let's search for requests that are min duration of 1 second. And where the feature flag variant returned was Benet. There isn't any. Okay, let's try recursive. And you can see, indeed, all of the traces that were recursive were above 3 seconds in this case. So this is the kind of integration that you can get with OpenFeature. This is kind of what open standards kind of get you. I would have loved to, in this demo, also demonstrate Prometheus integration to show you some metrics. You can see how many users, say you have a complex set of rules, right? Rules are now abstracted from the development team. You could have a set of 30 complicated business rules that are factors in a particular flag variant being returned. If you wanted to see metrics on what that actually means for the variants that are being returned in terms of percentages being shown to users, that's something that Prometheus, Grafana, could definitely help you with. And again, it basically comes out of the box with OpenFeature, just a single line of code, and then you have that instrumentation no matter what feature flag backend you're using. So that's my demo. I'd wish that last one had worked, but that's the way it goes, I guess. Hopefully you guys get the idea. I'm just going to show one last slide here for all our contact information. So if you want to get involved in the OpenFeature project, which, yeah, I'd love for you to, especially if you're interested in developing Python or Ruby. We're working on SDKs for those. Please visit us on GitHub. OpenFeature.dev is our website. Or you can find us in the CNCF Slack, which is free to join. I think that's it.